So in this video, we're going to talk about inscribed angles and then inscribed quadrilaterals. So an inscribed angle is an angle with the vertex on the circle. Okay, so you can see this angle, the vertex of the angle is on the circle itself. The two sides are chords because they're cutting across the circle. They're not going outside the circle, they're just hitting it in two places. So an intercepted arc is the arc that lies between the end points of an inscribed angle. So, I'm actually do this in a different color. So, intercepted arc is going to be AC right here, okay? So, the degree of the inscribed angle is equal to half the measure of the intercepted arc. So over here, if you have angle ABC, so that's what I outlined in pink, angle ABC, it's going to be half the measure of arc AC, okay? So now, what if we are intercepting through a diameter? So essentially a triangle is on the inside. So if an inscribed angle intercepts a diameter, then it has a right angle. So right here, it's going to form that 90-degree angle. So angle BAC is going to be 90 degrees. If you have arcs that are overlapping, so if two inscribed angles intercept the same arc, then those angles will be congruent. So if we have ABD, that angle right there, it's going to be equal to ACD because they are sharing that same arc of AD. Okay? So let's do a few examples together. Find each angle and arc measure. So if you notice in number 1, they gave us the arc measure of 62. So to find the angle x, or WXY, you're just going to divide it by 2. So 62 divided by 2 will be 31. So that's going to be the measure, 31. Okay? Looking at number 3, see how we have an inscribed triangle here? Well, you know that PQR, it's going to be 90 degrees because it is cutting through that diameter, so you can see that it's creating a triangle. So it's going to be 90 degrees. I should probably put a degree symbol for each of the angles here. So looking at number 5, this one's got a few more steps in it. So first off, I need to know what is the measure of this arc, and that will tell me what the measure of my missing angle is. So remember, a circle adds up to 360. So if I do 360 minus the other two measures that I have, so 65 and 53, you're going to end up getting 242 when you subtract it. So 242. So that is going to be the measure of my arc. So now to find the measure of the angle, you're just going to take 242 and divide it by 2. Because remember, the angle is half the measure of the arc. So 242 divided by 2 is going to be 121. So we're going to get 121 degrees. So now looking at number 6 here, these are going to be overlapping arcs. So angle RST, which would be this guy right here, and RUT, this angle over here, they are going to be equal to each other. So we need to figure out what is the measure of the arc, and we can use that to help find the measure of the angle. So similar to the last problem, you're going to do 360 and subtract it from the 3 measures you do have, because then that's going to tell me what the measure of this arc is. So if I do 360 minus 64 minus 75 minus 139, that's going to end up being 82. So that means the measure of the arc is 82. So I just need to take that arc, divide it by 2, and that'll tell me what my angle is. So we're going to have 82 divided by 2, and you get 41. And remember, since the arcs are overlapping, you know that the angle measures will be the same. So this will be 41, and that's going to be 41. Okay? So let's skip ahead to number 8. It says solve for x. So once again, you know that the angle is half the measure of the arc. So I'm going to take my arc, which is 4x plus 58, and I'm actually going to double my measure for the angle. So 2 times 67. Because remember, if I double the measure of the angle, it'll be the same as the measure of the arc. So we're going to have 4x plus 58. 2 times 67 is going to be 134. And then subtract 58 from both sides. So we're going to have 134 minus 58, which will be 76. Divide by 4. X is going to be equal to 9. And all we had to do was solve for x, so there we go. So now let's look at number 9. So once again, we need to solve for x here, but remember, we actually are intercepting a diameter here, and we have a triangle perfectly inscribed inside the circle, so you know that this angle over here is going to end up being 90 degrees. So we're going to take the measure 13x minus 1 and set it equal to 90. So we're going to have 13x minus 1 equals 90. So solve for x. So add 1 to both sides. So we're going to have 13x equals 91 divided by 13. And x is going to be equal to 7. And all we had to do was solve for x, so we're good to go. Looking at number 12, once again, solving for x. So the thing is, we need to find some of our missing parts on this circle here, because I need to know what this arc is, and that'll help me figure out the 5x plus 21. So if you notice, they tell us that the angle measure is 67. So for that, I can just double that, and that'll tell me the measure of the arc. So if I do 67 times 2, that's going to end up being 134. So this arc over here is going to be 134. So now I can use that to find the measure of this arc, and then I can set that equal to the 5x plus 21. So if I do 360 minus 134 minus 120, because we have this guy up here, the 120, that is going to get me 106. So 106 is going to be the measure of that blue arc. So now you're going to take 5x plus 21 and set it equal to that. So 5x plus 21 equals 106. So subtract 21 from both sides. So we're going to have 5x equals 85. And then you divide by 5. X is going to be equal to 17. So now let's look at 13. So they tell us if the measure of angle FGH, so it's going to be this guy right here, is going to be 6x plus 21, and then the measure of the arc FJH, so that would be this arc over here, is going to be 17x minus 28. We need to find the measure of the arc. So remember, the angle is half the measure of the arc. So what I want to do is I want to set these equal, but in order to do that, I need to take my angle and double it so that they end up being equal to each other. So we're going to have 2 times 6x plus 21 equals and 17x minus 28. So first you have to distribute, so we're going to have 2 times 6, which will be 12x plus 42 equals 17x minus 28. So I'm going to do 2 steps in one, so you're going to subtract 12x from both sides, and then add the 28 to both sides. And we're going to end up with 70 equals 5x. You divide by 5, and x is going to be equal to 14. So remember, that's not my final answer, because I need to find the measure of the arc itself, so FJH. So take that x and plug it in. So to find FJH, we're going to have 17 times 14 minus 28. So crunch those numbers real quick, and you're going to get 210 degrees. So 210. So now let's skip down to number 15. So these are overlapping arcs. So they tell us the measure of angle ABD, which will be this angle right here. I'll make that one pink. And then ACD, which will be this angle over here. Make that one blue. So we need to figure out the measure of the angles, and then we can use that to find the measure of the arc, because ultimately that's what we're going to have to find, AD, which is this piece right here. So remember, since they are overlapping arcs, the angles are going to be equal. So we're going to have 6x plus 26 equals 13x minus 9. So we need to solve this for x, so subtract the 6x from both sides, add the 9, and you're going to end up getting 35 equals 7x. You then divide by 7, and x is going to be equal to 5. So we can use that x to help us find the measure of the angle, and therefore find the measure of the arc. So since they're equal, it doesn't matter which one you plug into, so I'll go ahead and plug into ABD. So for angle ABD, we're going to have 6 times 5 plus 26. And so the measure of my angle is going to end up being 56 degrees. And so then to find the arc, you take that 56 and multiply it by 2, because remember, the angle is half the arc. So to find AD, you're going to have 56 times 2, and that's going to end up being 112. Okay? So now let's look at number 16. So this time we have the intercepting diameter, so an inscribed triangle. So we have KJL, which is this angle over here, and then KLJ, which would be this angle over here. And we need to use that to find the measure of arc KL. So KL is going to be this tiny little piece over here, that tiny little arc. Okay? So remember, if you have an inscribed triangle, it's creating that 90-degree angle, and triangles add up to 180, so if I do 180 minus 90, the remaining two angles should add up to 90. So take your two angles, so 3x plus 2 plus 7x minus 32, and set them equal to, sorry about that, set them equal to 90, because that's what the other two angles should add up to. So combine like terms, and you're going to get 10x minus 30 equals 90. You then add the 30 to both sides, so 10x is going to be equal to 120. Divide by 10, x is going to be equal to 12. All right? So now, similar situation, I need to figure out the measure of the angle, and then we'll use that to find the measure of the arc. So the one we're going to plug into is definitely KJL, because that's going to be the angle that lines up with arc KL. So for angle KJL, we're going to have 3 times 12 plus 2, and that's going to end up being 38. So 38 is the measure of the angle. So then to find the arc, you have to double it. So arc KL is going to be 38 times 2, which is 76 degrees. So now let's look at inscribed quadrilaterals. So if a quadrilateral, which is a four-sided figure, if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. So supplementary means it adds up to 180. So angles A and C are directly across from each other, so they add up to 180, and then D and B are directly across from each other, so they add up to 180, and that's what these equations are down here. Okay? So let's do some examples. Looking at number 1, find each value or measure. So to find the measure of angle J, look for the one that it's across from. It's across from L. So L has a measure of 92. So I just need to do 180 minus 92, and we're going to get 88 degrees. Okay? So now to find angle K, that one is directly across from M. So for that, I just need to do 180 minus 45, and that's going to end up being 135. Easy enough. So now let's look at number 3. Okay? So once again, I need to find all my missing angles. So the first one that you can find pretty easy is angle W, since W and Y are across from each other. So for that one, I just need to do 180 minus 51. And when I do that, I'm going to end up getting 129 for angle W. So now for V and X, I don't know one of those, so I need to do a little bit more work to figure that one out. But if you notice, they give us this arc measure over here. So I can add those together. We can add them together and then divide by 2, and that's going to tell me the measure of the angle for X. Because if you notice, angle X opens up like that, and it perfectly lines up with that purple arc. So if I do 101 plus 67, I'm going to end up getting 162. So when I divide by 2, that's going to tell me the measure of angle X, and that's going to end up being 84. So draw a little arrow to X here. It's going to have a measure of 84. So now I can find V, because V is directly across from X. So if I do 180 minus 84, that is going to give me a measure of 96. So let's do some more. So let's look at number 6. So for this one, we just have to solve for X. So if you notice, remember we need the angles that are opposite from each other. So T and V are directly across from each other. That's what I want. So now just add them together and set it equal to 180. So if I have 62 minus 5x plus 133 equals 180. So do a little bit of algebra. You're going to do 62 plus 133. And I'm going to have 195 minus 5x equals 180. You're going to subtract the 195 from both sides, and you're going to get negative 5x equals negative 15. Divide by negative 5, x is going to be equal to 3. And all we have to do was solve for x, so we are done. Now let's look at number 7. So once again, it says solve for x. So we have angle L. However, I need to figure out what my other angles are going to be, because the one that I need for this is going to be angle N. So once again, if you notice, the way angle N opens up, it lines up with this arc over here. So actually, let me do that in a different color. So we'll do it in blue. So if you notice, they tell us the measure of the two smaller arcs that make up the big arc, so 91 and 135. So let's add those together. So 91 plus 135, and we're going to end up getting 226. So that's going to be the measure of the big arc, 226. So now to find the measure of angle N, you would just divide by 2. Because remember, the angle is half of the arc. So if I divide by 2, I'm going to end up getting 113. Okay. So now I have the measures of the opposite angles. So add those together, set it equal to 180. So we're going to have 15x minus 23 plus 113 equals 180. So do a little bit of algebra. So we're going to have 15x, and then negative 23 plus 113 will be 90, and then equals 180. So now subtract the 90 from both sides, and you're going to have 15x equals 90. Divide by 15. X is going to be equal to 6. And we decided to solve for x, so we are done. And now let's look at number 9, last one. So they tell us that angle W, this guy right here, is going to be 5x plus 1. And then angle Y, 13x minus 37. So if you notice, they are directly across from each other. That's what I want. And then ultimately, we need to find the measure of angle Y. But first, I got to know what x is. So, not angle x, but just regular x in the problem. But like I said, so angles W and Y are directly across from each other, so add them up. So we're going to have 5x plus 1 plus 13x minus 37 equals 180. So 5 plus 13, we're going to get 18x minus 36 equals 180. Add the 36 to both sides, and we're going to have 18x equals 216. Divide by 18, x is going to be equal to 12. So now that I know what x is, we're going to take it and plug it in to y up here. So to find angle y, we're going to have 13 times 12 minus 37. And we're going to end up getting 119. And that's how you work with inscribed angles and quadrilaterals.